Hello friends, here we are going to start first problem on simple stresses and strains. In the previous video, I explained you the different types on simple stresses and strains. See here is the very important thing. It is the problem on elastic constants. See, while solving any problem, you should have the list of our formulas. Already I explained you the different formulas. Just here the summary which is required to solve the problem on elastic constants. Important formulas related to the elastic constant. That is EV is equal to delta V upon V. Mu is Poisson's ratio, that is lateral strain upon a linear strain. Tau, that is shear force upon shear area. E is equal to 3K in bracket 1 minus 2 mu bracket complete. That is the relation between E and K, means relation between modulus of elasticity, that is Young's modulus, and K, that is bulk modulus. Here G is equal to tau upon phi. So the relationship between E and G, that is modulus of rigidity, that is G, E is equal to 2G in bracket 1 plus mu. Here the formula for bulk modulus is equal to sigma upon EV, and relationship between E, K and G, the formula is E is equal to 9 kg upon in bracket 3K plus G. So please note down all the formulas, make a list of all the formulas. So while solving the problem, you feel very easy. See, the first problem, that is the university problem, the December 2010, the problem is for 5 marks. Material has Young's modulus of 2 into 10 raised to 5 Newton per mm square and the Poisson's ratio of 0.32. Calculate the modulus of rigidity and bulk modulus of the material. See, again, see the problem. A material has Young's modulus of 2 into 10 raised to 5 Newton per mm square and Poisson's ratio of 0.32. Calculate modulus of rigidity and bulk modulus of the material. So here, first of all, you have to write the given data. In the given data, Young's modulus is given, that is 2 into 10 raised to 5. So E is equal to 2 into 10 raised to 5 Newton per mm square. The Poisson's ratio is given, that is 0.32. So mu is equal to 0.32. Here you have to find out modulus of rigidity, that is G, and bulk modulus, that is K. So we have the formula for modulus of rigidity, and we know that relation between modulus of rigidity and Young's modulus. So we know that formula is equal to 2G in bracket 1 plus mu. Here we have the value of E, that is Young's modulus. We have the value of mu. So after putting the value of E, that is 2 into 10 raised to 5 is equal to 2G in bracket 1 plus 0.32, you will get the value of G. So the G is equal to 2 into 10 raised to 5 upon 2 into 1.32. You will get G is equal to 75.76 into 10 raised to 3 Newton per mm square. So the another unknown, that is bulk modulus, but we know that the relationship between E and K. So again, E is equal to 3K into 1 minus 2 mu bracket. Here we have the value of E, we have the value of mu. There is only one unknown, that is K, that is bulk modulus. So E is equal to 2 into 10 raised to 5 is equal to 3K in bracket 1 minus 2 into mu. We have the value of mu, that is 0.32. After putting all the values in the formula, k is equal to 2 into 10 raised to 5 upon 3 into 0.36. So the answer will be 1.25 into 10 raised to 5 Newton per mm square. While putting the values in the calculator, you have to take proper care, then you will get the right answers. Here, one more problem you can see. Dear friends, here I am explaining the problem because already I explained you the theory. I know the speed of explaining is high, but I have given E content to you, and in minimum time we have to complete so many problems. So here I am explaining each and every problem to you. Just refer each and every problem very clearly. Definitely you will get the entire idea about the subject, and definitely you will score in this subject. You will get maximum knowledge of this subject. So here one more problem. Please read this problem very carefully. A bar of 20 diameter is subjected to a pull of 50 kilonewton. The measured extension over a gauge length of 20 centimeter is zero point 0.1 mm, and the change in diameter is 0.0035 mm. Calculate the Poisson's ratio and modulus of elasticity. See the list of formulas, very important. This problem is from May 2009 for 8 marks. First of all, make a list of given data. The bar diameter is given, that is 20 mm. Subjected to a pull of 50 kilonewton, means P is given, is in 50 kilonewton. So you have to convert into Newton, that is 50 into 10 raised to 3 Newton. The measured extension over the gauge length of 20 centimeter is 0.1 mm. So the length is given, that is in centimeter. So 20 centimeter is equal to 200 mm. You have to convert into mm. 0.1, that is delta L. So change in length, that is 0.1 mm. Delta D, that is change in diameter, is also given, that is 0.0035 mm. And here they ask you mu and E. Mu is the Poisson's ratio and E is the Young's modulus. So to calculate Poisson's ratio, we have to calculate lateral strain and linear strain. That is EL upon E is nothing but a Poisson's ratio. So first of all, we have to calculate the value of EL and E. So here, see this. First of all, to calculate a linear strain, delta L upon L, we have the value of delta L, that is 0.1, and L is 200. So 0.1 upon 200, you will get 5 into 10 raised to minus 4. See, strain is unitless quantity, so there is no any unit. So lateral strain is nothing but a delta D by D. Already I explained you what is by linear strain and what is by lateral strain. So here delta D by T, we have the value of delta D. Delta D value is given, that is 0.0035 upon D, that is 20. So answer will be 1.75 into 10 raised to minus 4. So here we have the value of linear strain and we have the value of lateral strain. Just putting the value of lateral upon linear, you will get the Poisson's ratio. Here the value of lateral strain, that is 1.75 into 10 raised to minus 4 upon linear strain, that is 5 into 10 raised to minus 4, you will get 0.350. That is the Poisson's ratio. The area A is equal to pi by 4 into d square, because the diameter is given, means bar is circular. So cross sectional area is equal to pi by 4 into d square, that is pi by 4 into 20 square is nothing but 314.16 mm square. Because to calculate modulus of elasticity E, you should have the value of stress and strain. Here we have the value of linear strain, but we don't have the value of stress. And we know that stress is equal to load upon subjected cross-sectional area. Here we have the value of load. The value of load is given in the problem. We have the value of subjected cross-sectional area. So stress is equal to P by A. So P is 50 into 10 raised to 3, and subjected cross-sectional area is equal to 314.16. Here we have the value of linear strain, that is 5 into 10 raised to minus 4. So you will get the modulus of elasticity 3.18 into 10 raised to minus 5 Newton per mm square. See, just by using the simple formulas, you can solve this type of problems. See, one more problem is from December 11, that is for 5 marks. If a round bar of 37.5 mm diameter and 2.4 meter length is stretched by 2.5 mm, find its bulk modulus and lateral contraction. Take Young's modulus is equal to 110 giganewton per meter square, and shear modulus is equal to 42 giganewton per meter square for the material of the bar. See, after reading each and every problem, you have to write down the given data very clearly. See, the diameter is given, the round bar of 37.5 mm diameter. So you have to write D is equal to 37.5 mm diameter. And 2.4 meter length is stretched. So L is equal to 2.4 meter. Here you can consider all the dimensions in mm, or you can consider all the dimensions in meter. If you want to convert this diameter into meter, so diameter is given in mm. So while converting in meter, you have to multiply by 10 raised to minus 3. So the value of D is equal to 37.5 into 10 raised to minus 3 meter. Here, stretched by 2.5 mm is given. So delta L is equal to 2.5 mm. So again, the value will be 2.5 into 10 raised to minus 3 meter. Young's modulus, that is 110 giganewton per meter square. So 110 giganewton. So to convert into Newton per meter square, you have to multiply by 10 raised to 9. So 110 into 10 raised to 9 Newton per meter square. Here G is given, that is shear modulus is given, modulus of rigidity is given. G is equal to 42 giganewton per meter square. So value will be 42 into 10 raised to 9. Already I explained in the previous videos what is meant by kilo, what is meant by mega, what is meant by giga. So using the relationship E is equal to 2G 1 plus mu, you can solve the problem. We have the value of E. We have the value of G. Here we have the value of E and we have the value of G. So by using this relation, E is equal to 2G 1 plus mu, that is mu is nothing but 1 upon m. you will get the value of mu. See here, we have the value of mu, that is 0.30 into 9, 0.30952. And after getting the value of mu, you can calculate the bulk modulus, because we have the value of E, we have the value of mu. So by putting the value of E and mu, you can calculate the value of K. Here we have the value of E, that is 110 into 10 raised to 9 Newton per meter square. That is the value of E. We have the value of mu, that is 0.30952. Just putting the value of E and mu, you will get the value of K. See, by putting the value of E and mu, you will get the value of K, that is bulk modulus. So here the value of bulk modulus is 0.96 into 10 raised to 5 Newton per mm square. Now we have bulk modulus, we have modulus of rigidity, we have Young's modulus. Here the longitudinal strain E is equal to delta L upon L. You will get the value of E. Now we have the longitudinal strain E. We can calculate lateral contraction. See, we know that Poisson's ratio is equal to lateral strain upon longitudinal strain. Here we have the value of longitudinal strain. Just put the value of mu and longitudinal strain in the given formula, you will get a lateral strain. See, the lateral strain is equal to 3.223 into 10 raised to minus 4. Now we have the lateral strain. So once you will get the value of lateral strain, you will get value of lateral contraction. So here lateral strain is equal to lateral contraction upon original lateral dimension. So you can see here, we have the value of lateral strain, that is 3.223 into 10 raised to minus 4. And we have the original lateral dimension, that is 37.5 into 10 raised to minus 3. We have taken this value in meter. So you will get the lateral contraction, that is 1.208 into 10 raised to minus 4. That is the value of lateral contraction. See, all the problems are just based on the formulas. You can refer our e-notes to solve each and every problem. Here just see important formula for uniaxial force system, biaxial force system, triaxial force system. Already I explained all the things. Here, a steel rod of 5 meter long and 20 mm in diameter is subjected to an axial tensile force of 1000 kilonewton. Find the changes in length, diameter, and the volume of rod. Take E is equal to 200 GPa and Poisson's ratio is 0.3. The problem is from December 15 for 4 marks only. See, you have to make a list of given data and what is required to find out. Steel rod of 5 meter long and 20 mm in diameter means length is given and diameter is given. Axial tensile force of 1000 kilonewton means P is also given, that is 1000. You have to find out change in length, change in diameter, and volume of the rod. E and mu is given. So here you have to calculate area first. Diameter is given, so circular. So So area is equal to pi by 4 into d square. You will get the area pi by 4 into 20 square. That is 314.15 mm square. The next, we have to calculate stress. That is sigma. Sigma is equal to P by A is equal to 1000 into 10 raised to 3. Because value is given in kilonewton, you have to convert in Newton. So multiply by 3 upon subjected cross-sectional area, that is 314.15. Here the answer is 3183.19, 3183.19 Newton per mm square. Now we have to calculate change in length. We know that the formula for change in length, that is delta L is equal to PL upon AE. Here we have the value of P, we have the value of L, we have the value of area, we have the value of E. So you have to just put all the values in the formula. P is 1000 into 10 raised to 3, L is 5000 mm, area, that is 314.15, E is 210 into 10 raised to 3 is in Newton per mm square. So we have taken 210 into 10 raised to 3. We will get the value of change in length. After getting the value of change in length, you can calculate a lateral strain, that is EL is equal to mu into E. E is nothing but a delta L upon L. So we have the value of delta L, we have the value of L, you will get the lateral strain. Now we have the value of lateral strain. So we can calculate change in a diameter, that is delta D is equal to lateral strain into diameter. We have the value of diameter, here you will get the change in diameter. And we know that volume metric strain EV is equal to sigma upon E 1 minus 2 mu. We have the value of sigma, we have the value of Young's modulus. You will get the volumetric strain. After getting volumetric strain, you can calculate change in volume, that is delta V upon V is nothing but EV. So here change in volume, delta V is equal to EV into volume. Here we have the value of volumetric strain. Just you have to put the value of volumetric strain, that is 6.0632 into 10 raised to minus 3. And we know that the volume is nothing but area into length. So here the area is 314.15 into 5000. You will get the change in volume, that is 9523.8 mm cube. See, the unit is very important, mm cube, because it's a change in volume. Make a list of all the formulas. It will be very useful to solve all the university problems. So one more problem. Steel block 360 mm into 1880 mm into 160 mm is subjected to the following forces. Tensile force of 1280 kilonewton on the 160 mm into 80 mm faces. Take as a x direction. Tensile force of 3456 kilonewton on the 360 into 80 mm faces, take as a y direction. And a compressive force of 5184 kilonewton on the 160 mm into 360 mm forces, take as a z direction. Find change in dimension of a block and also change in volume. Take E is equal to 2 into 10 raised to 5 Newton per mm square, and Poisson's ratio is equal to 0.25. This problem is for 10 marks. Very simple problem. Already I explained you what is by uniaxial, biaxial, and triaxial. Here stresses in each direction is given. So just note down stresses in each direction. Px is given, Py is equal to given, and Pz is also given. Here in this condition, compressive force is given as a z direction. So here E is equal to 2 into 10 raised to 5 Newton per mm square is given, mu is given. You have to calculate sigma x, sigma y, and sigma z. Sigma x is nothing but Px upon A. We have the value of Px upon area, that is 160 into 80. See here 160 into 80 is given. Sigma y, that is Py upon A. So Py value of, we have the value of Py, the compressive given. So minus 5184 into 10 raised to 3, that is 360 into 160, and sigma z is also given, that is 3456 into 10 raised to 3. Area is given, that is 360 into 80. See here area is given. See there is a minor change. Please note down this change. The third point is related to y direction, and the second point is related to x direction, z direction. So we know that strain in each direction. We have the formula of Ex, Ey, and Ez. Here you can calculate the value of Ex, Ey, and Ez. We know that Ex is equal to sigma x upon E minus mu into sigma y upon E minus mu into sigma z upon E. So here this is the formula for Ex, similar the formula for Ey, similar the formula for Ez. We have the value of Young's modulus. We have the value of sigma x, sigma y, and sigma z. Just put the value for Ex, Ey, and Ez. You will get the value of Ex, Ey, and Ez. These are the stress in x direction, y direction, and z direction. After putting the values in this for the equation, you will get the answer. So Ex is equal to 0.4625 into 10 raised to minus 3. Ey is equal to minus 0.725 into 10 raised to minus 3. Ez is equal to 0.5875 into 10 raised to minus 3. Here you will get total strain is equal to Ex plus Ey plus Ez. So EV, that is total strain, you will get in this formula. That is 0.325 into 10 raised to minus 3. Now, just you have to calculate change in dimension. You know that change in length is equal to delta L upon L, that is in x direction. So delta L is equal to Ex into L. Change in thickness, that is delta T, is nothing but Ey into T. Change in width, that is delta B, is nothing but Ez into Eb. And change in volume, that is equal to delta V is equal to Ev into V. Here we have the value of L, we have the value of T, we have the value of B, and we have the value of volume. Volume is nothing but L into T into B. Here we have all the dimensions. Just we have to put the values. You will get change in length is equal to 0.1665 mm. delta T is equal to 0.058 mm. Change in width delta B is equal to 0.094 mm, and change in volume delta V is equal to 1497.6 mm cube. Please, in this formula, keep in mind the compressive force. The third point is in y direction and second point is in z direction. Then you will get the right answer. There is a minor correction. Please do that correction and solve the problem according to the formula. You will get the answer. Similar problem is given, that is rectangular block is loaded as shown in figure. Find the change in dimension and also change in volume. Take Poisson ratio, that is 0.3. E is given, AB, BC and AE lengths are given. PX, PY and PZ is given. PX is tensile, PY and PZ, that is negative, means it's a compressive. Again, we know that here I am not wasting that much time to explain this problem because already I completed this sigma x, sigma y and sigma z. While calculating sigma y and sigma z, the sign will be minus because given load is also in minus, means compressive. Negative sign indicates that it's a compressive. So you can see this diagram. Similarly, you have to calculate Ex, Ey and Ez. After calculating Ex, Ey and Ez, you will get the volumetric strain EV, that is sigma Ex plus Ey plus Ez. Once you will get the value of Ex, Ey and Ez, you can calculate change in length, that is the delta L. You can calculate change in thickness, that is delta T. You can calculate change in width, that is Ez. You can calculate change in volume. See, this problem is same as previous, so you can solve this problem very easily. Just you have to see this problem. 1000 is acting away from the point, that is a tensile. This 2000 is compressive. This 500 is also compressive. So you have to calculate sigma x, sigma y and sigma z. To calculate sigma x, formula is px upon area, that is subjected cross sectional area. You have to refer this diagram for the subjected cross sectional area. Automatically you can solve this problem. Thank you very much.